The following project is the first partial exam of the embedded systems where we develop a library to communicate Labview with pic18F45K50. In order to communicate both systems, we have created 4 sub-VIs, each one with one specific instruction: digital read, digital write, analog read, and analog write. Let's take a look to digital read sub-VI. Okay.
We use the Visa library to establish UR communication. In every sub-VI, we send 2 bytes with the whole information. So, with an enum and a case structure, we decode the pin that will execute the command. After sending the 2 bytes, we expect to receive a byte with the state of the selected pin.
Okay.
In the digital write,
in the digital write sub-VI, the only difference is that we don't expect any data from the PIC, and the state is including in the 2 bytes. So this is the button state, and this button state is going to change the byte in order to receive the command of the state.
for analog read, we send a command to receive a byte that has a number from 0 to 255. Finally, the analog write we only send a 0 to 5 volts double number. We converted it to a byte and use it the CCP2 pin from the PIC to PWM.
Okay, let's take a look to the whole main with the 4 sub-VIs. We have a circuit to prove all the sub-VIs. This is the main. We have every sub-VI, digital read. We are going to digital read pin 0 from port B, pin 1, pin 2, pin 3. And the button states of the digital write also of port B. And we have the ADC. We're going to read 4 ADC pins. And then finally, we're going to put the PWM of the pic45K50, and every sub-VI has its error handler at the at the end of this at the end of the VI of the main. We have the simple error handler. So this is the
Demonstration
front panel. Okay, so first we're gonna move the potentiometers, and the potentiometers are holding in the pin 1, pin 2, and pin 3.
Next, we are going to test the digital read. There are these 4 switches. One represents a LED in the front panel. If we change the state, it will change the state in the front panel.
Okay.
Next, we can test the digital write with these buttons. We click it, and the state of the LEDs will change depending on the state of the LED on the front panel. Finally, we can select a value in this slider to write it in the PWM. This is a 5 volts. This is 0, and this is like 2.5 volts.